For today's lesson, we will be simplifying algebraic expressions. And these are our two lesson objectives listed here, along with our standards being addressed in this lesson. Starts with 6EE3, 6EE4, and then 6EE6 will be our three standards addressed in today's lesson. So what we're going to try to do is we're going to try to make these algebraic expressions as small as possible. And so if we have a straw of length y inches and we join it to another straw of the same length, we want to find the total length of the two straws. Well, one thing you could do is take the length of the first straw and then add it to the length of the second straw. Well, if you use your knowledge on multiplication, if you remember back to when you were first learning how to multiply, if you had a number 4 plus 4, you could rewrite that as 4 times 2. Well, in this case, we are adding a number to itself, so we could multiply that by 2. So y plus y is 2y. Here we have an equilateral triangle. We know it's equilateral because all the sides are congruent. And so if I were to ask you to find the perimeter of the triangle, you could take p plus p plus p. Well, now we're taking a number and adding it to itself 3 times. So it would be 3p would be your simplified expression. If we have 6 rods and their lengths, we want to find the total length of the 6 rods in terms of z. So we would take the 6 sections and we would add those together. Z plus z plus z plus z plus 2 plus 5. When simplifying expressions, we are doing what's known as combining like terms. And in order to be like terms, numbers must use the same variable. So in this case, we will not be able to combine everything because the 2 and the 5 do not have z's. But we could take the 4 z's and put them together to get 4z. And then we would do 2 plus 5, which is 7. And that's as far as we can go with this because the 7 does not have a z. Now the second part says, then state the coefficient of the variable in the expression. So in this case, our coefficient is 4. The coefficient goes with the variable. Now the 7 does have a special name as well, and a number like 7 is known as the constant. So here we need to simplify the expression and then state the coefficient. So for number 1, our simplified expression would be 5x with a coefficient of 5. Number 2, our simplified expression would be 2y plus 6, and we'd have a coefficient of 2. For number 3, our simplified expression would be 3m plus 9 with a coefficient of 3. And then our final one here, our simplified expression would be 6n plus 4 with a coefficient of 6. I'm going to scroll down a little bit. Square has sides of length x centimeters. Find the perimeter of the square in terms of x. Well, if it's a square, all of the sides would be congruent, so they'd all be x. So your perimeter would be x plus x plus x plus x, or 4x. And here we have a trapezoid, and we want to find the perimeter of the trapezoid in terms of w. So you would have 10 plus w plus w plus w. So you would have 3w plus 10. For our like terms, our coefficient does not have to start or our variable does not have to be without a coefficient. It can start with one. So if we were to simplify 3x plus x, we can think of it as if you have 3x's and somebody gives you another x, you would have 4x's. 4z plus 2z, same idea. If you have 4z's and somebody gives you 2z's, you would have 6z's. So if we were to simplify x plus 8x, you would get 9x. 3r plus 2r would be 5r, and then 5y plus 6y is 11y. So starting with number 10, we are determining if each pair of expressions is equivalent. So for number 10, if we take a plus a plus a, we would get 3a. Well, 3a is the same as 3a. So yes, those are equivalent. 2h plus 2h is 4h for number 11. 4h is the same as 4h. So yes, they are equivalent. For number 12, we have had 2k plus 5. K plus k is 2k. But adding 5 is not the same as multiplying by 5. So they are not equivalent. 6z plus 4z is 10z. Well, 10z is not the same as 10 plus 2z. So they are not. 1p plus 3p is 4p. 4p is not the same as 13p. So they are not equivalent. The only time they would be equivalent is if the value of p was 0. And number 15, 3n plus 4n is 7n. So 7n plus 2 and 2 plus 7n are equivalent. You can switch around your order in addition, so they would be equivalent. And it's the same idea with subtraction. If you have two v's and I take a v away, you'd be left with one v. But we don't write one v because if we write 1v, that stands for 1 times v. Well, a number times 1 is itself, so you would just have v. 5w minus 3w is 2w, and y minus y is 0. It's not 0y because, again, it stands for multiplication. 0 times anything is 0. So 4s minus s would be 3s. 12z minus 7z is 5z. 3p minus 3p is 0. So for numbers 19 and 20, we're determining if expressions are equivalent. Number 19 is no. They are not equivalent because you cannot switch the order in subtraction. The one time when they would be equivalent is when f is equal to 6. And then number 20, yes, they are equivalent because 5c minus 5c is 0 and a minus a is 0. So there's the lesson for today. As always, I hope this helps.